We do have three plenary speakers here for this session who will present their views about this exciting time for engineering now and in the future, and their perspectives from the industry, academia, and government. We are indeed fortunate to have this opportunity in celebration of our golden anniversary. It gives me great pleasure really to introduce Eric Schmidt, the Executive Chairman of Google Incorporated, Francis H. Arnold, the Dick and Barbara Dickinson Professor of Chemical Engineering, Bioengineering, and Biochemistry at the California Institute of Technology, and Sally Jewell, Secretary of the U.S. Department of Interior. Speaking first is Eric Schmidt. Eric joined Google in 2001 and helped grow the company from a Silicon Valley startup to a global leader in technology. He served as Google's Chief Executive Officer from 2001 to 2011, overseeing the company's technical and business strategy alongside founders Sergey Brin and Larry Page. All three of them, by the way, are NAE members. Under his leadership, Google dramatically scaled its infrastructure and diversified its product offerings while maintaining a strong culture of innovation, which is what he's going to talk about today. Please, Eric, the floor is yours. Thank you very much for being the first of our plenary speakers at our centennial celebration. And I think you need to speak fairly close to this microphone. I am told by the people in the back they cannot hear us unless we are speaking close to this mic.
Okay, thank you very much.
Thank
you very, very much. Thank you all. I'll bend over a little bit. I'm a very proud member of the National Academy of Engineering, and it's a real pleasure and honor for me to be here today. I wanted to begin with a comment about the 1964 World's Fair. And I think folks know about it. Of course, this is when this institution was invented. And Isaac Asimov, at the time of that fair, wrote a very famous set of predictions anticipating a 2014 World's Fair. And anticipate with me and imagine that we're at that World's Fair. This is what he said. Much effort will be put into the designing of vehicles with robot brains, vehicles that can be set for particular destinations and that will then proceed there without interference by slow reflexes of a human driver. I suspect one of the major attractions of the 2014 fair will be rides on small roboticized cars which will maneuver in crowds at the 2-foot level, neatly and automatically avoiding each other. Isaac Asimov. Now, how did he anticipate? This is 1964, and judging from the audience, a few of you were alive there, but not most. He anticipated, remember, the IBM 360, which was the first computer that I used seriously, which had 1 megabit of water-cooled core memory, had just been invented in 1964. How did this brilliant man anticipate the integrated circuit, GPS, robotics, and artificial intelligence? Part of the way that he saw this is he could see the compounding of innovation and the rate of scale. And that's what I really want to talk about. I want to talk about why this stuff is so important. What we're seeing right now is we're seeing an explosion in innovation that is unparalleled. And this sort of massive investment in this whole new global tech elite around the globe is moving stuff much faster than any of us ever anticipated. It's happening because of the integration that the US took 50 years for GDP to double. China did the doubling in 15 years. And it took 60 years for air conditioning to get 80% of US citizens. I grew up here. I understood Washington, D.C. without air conditioning, trust me. And it took 10 years for 80% of Americans to have mobile phones. Think about the compounding that's occurred in our lives together. Now, what are some examples of this? Uber allows us to rethink public transportation. It's really called the sharing economy. Tesla, who thought the automobile could be reinvented, but indeed Tesla has done so, literally reinventing the way you use a car. Solar power is now at a purchase price parity with natural gas, with the U.S. about to surpass Saudi in oil production in a decade. We're already #1 in natural gas. If you'd have said that 10 or 20 years ago, people would have said, you're crazy. Software is transforming every market. Literally everything, including even food and groceries to your home. Who would have expected that? And we'll talk about this in a bit. Real-time, non-invasive monitoring of your health connected to these mobile phones. You think the mobile phone is important? Wait till it tells you, call the hospital right now. And if you pay a fee, maybe the app will let you it'll call automatically. No, that was a joke. But you get the idea. You get the idea. Come on, you get the idea. Imagine, you think of this phone as something that you actually talk on. And by the way, those of you who have children and grandchildren, no one talks on the phone anymore anyway, they just text. But I digress. So why does this matter so much? Well, if you talk to economists, as I am forced to do all the time, they will tell you that that human progress has always occurred as a result of innovation, industrialization, the transformation, and ultimately invention. Here's a statistic for you about job creation. It's from a guy named John Halterwanger, who studies this. We have found that startups together with high-growth firms, which are disproportionately young, account for roughly 70% of overall job creation in the United States. You want to know how to solve the job problem? More innovation, more investment in what we do, more entrepreneurs, more new at-bats. It's that easy. All this other stuff doesn't account for it. You want to solve the problems in America? Do it that way. So I've thought about this a lot, and I think that we're missing some language about this. We're still caught in the old taxonomies of language and thinking. And let me give you a set of observations. One, I think, is that scale matters a lot. Now, what do I mean by scale? And I'm going to propose that there's a new businessman's lament, or businesswoman's lament globally, and it goes like this. How do we make our money in a globalized market where scale is everything? In other words, if you're the scale platform, that's the globalized scale platform, you can do pretty well. But what if you're not? What if you're not the platform innovator? What if you're not the most efficient producer of some good or service in the world? Well, in a market that's so completely connected, you've got to do something else. So what are some examples here? The ruthless efficiency of Amazon, the effectiveness of Apple Computer. We've already seen this in, for example, the effectiveness of Chinese Shenzhen manufacturing, which revolutionized manufacturing and really changed the economics of inflation in America. And there's this bizarre dichotomy of local control, which we want, by the way, and global platforms. So there are examples of small countries that have managed to do this. Think about Scandinavia, Denmark, Hong Kong, Singapore, or in business, think about specialized brands like Bose, where they've ultimately, even though they're not the largest country or the largest provider, they figured out how to do something very special. So the new rules effectively are you have to drive a platform, or you have to be so much better than the common platform that you can hold on to that market or that identity or that leadership. And what's interesting is people really want local control, but the scale really helps platforms. And because of the arrival of the internet, I think we're struggling with this question. We're struggling with, are we the local control? In other words, this is the Scotland example, parenthetically. Local control versus part of a larger ecosystem. They voted, of course, to be part of the larger ecosystem, but you see it played out over and over again. I'll give you another example of what's going on. I'm going to say that culture and creativity matters. This is a quote from Jim Cameron, the well-known movie director, but also a significant scientist in his own. There is nothing more powerful than someone who doesn't know what they can't do. Right? And by the way, Jim was the man who went to the bottom of the ocean for the only second time in a vehicle that you couldn't even get me to get in on land. Right? That's how courageous this man is. And it's interesting that when you think about the history that we learned about, Marxism has been discredited largely because it was agrarian in its nature. And we're not an agrarian society anymore. We're a knowledge worker society. And what's interesting, if you look at China, China's scale works except for the air that you have to breathe. But at least they have a large enough and coherent enough domestic market that maybe they'll get through this. But I would say to you that if you want to address Jim's point, which I think we do, you have to create a space for new ideas. And there's this sort of relentless need to regulate all sort of new ideas out of a system, right? So my current favorite example is, imagine that we're sitting here and we've arrived all by horse and buggy, and one of you, as scientist, has just invented the car, okay? And you've driven it up, and we're all looking at the horses. What is the probability that that car will be legal tomorrow on the streets of DC? Think about it. You see my point. In other words, you have to have a place where you can take the cars, right? You actually have to have a place where you can try this. Aviation, I'm a pilot. Aviation was the same thing. It was completely unregulated, and these people killed themselves all of the time. And you need an appropriate amount of regulation, but if you ban aviation, you'll never experiment and discover that it's amazing to fly around. You get the idea. And so there's this interesting and stifling effect of needing to ask permission. So you need to create economies and efficiencies in science where you can just do it, right? Where you can say to this typically young dreamer, just try it. Try not to kill yourself, please, right? Take the risk. And over again, we face the challenge that someone else doesn't have those regulations and can do it. And we need to face this as both a country but as a society. This innovation is central. There are plenty of possible solutions to this. The most obvious one is having regulations have time limits. I doubt that will occur, but it's worth thinking about. If you fundamentally believe that innovation and new ideas drives everything, make sure the space exists. I'll give you another example. I think that research and research funding matter an enormously more than even you all think about it. There's an African proverb, if you want to go fast, go alone, but if you want to go far, go together, right? So how did all of this, how did the buildings around us, how did the power, how did the electricity, how did all the cars and so forth? Because our predecessors who have since died had the courage to work together to fund. They created, among other things, the National Academy of Engineering and so forth and so on. I mean, it's interesting that I was studying this, that 16 of the top 20 universities are in the United States. Think about, that's why I'm here, right? That's why you're here. 100 years ago, somebody said, wouldn't it be really nice if we had all of the best research universities in the country? And they put in place the decisions that would create that. It's an enormous asset for America. And a lot of the credit goes for this fellow named Vannevar Bush. Many of you know the history here. But basically, after the war, he was a part of the war effort in World War II. He actually took the steps to create the National Science Foundation and other federal funding models in the ways that ultimately funded, for example, young graduate students like myself. What's interesting is that 60% of all research now comes from federal funding. And this research and creative enterprise is very messy, but it's worth everything. It's what brought us everything. So how are we doing? Well, what are the numbers? Maybe we should have a fact-filled conversation in Washington, D.C., right? From a federal science point of view, the high point was $40 billion, and those numbers fell by $10 billion in a few years. Why? How could you possibly, as a government, not fund the most basic stuff for your future? The stuff that pays off 10, 20, 30 years from now. There's good news, and the good news is that private philanthropy and the people who I know quite well are working very hard to try to make some of that gap. If you add up sort of the sort of rich people's philanthropic, shall you say earmarks, to use a DC term, it adds up to about $125 billion over their lifetimes. So we're seeing people step in, but there's no substitute for the government funding, which is under continual attack, but more importantly, has been reduced on real terms. One of the numbers is that NIH funding has declined on an inflation-adjusted basis by 10% in real terms. Why in the world would you ever do that, given the possibilities and the inventions that are going on in the research universities of America? So one of the things that may occur as a result of having more funders is that science may actually change a little bit. And it may be that some of these new funders will have the patience and the commitment to go through and take huge bets, which I think is maybe the most exciting message of today's science. That some of the problems that I'll talk about in a minute may ultimately be attacked by a combination of federal, university, and individuals who basically say, I'm just going to try it, and I'm willing to fail. So what's going on in science? Well, I mean, here's my list. We have deep gains in molecular biology. We'll hear about that in just a minute. We are going to fairly soon know how the mind and brain really work, at least at an engineering level. We have real improvements of artificial intelligence. We will develop actual understandings of how humans work, think, live and play. There's a physics revolution, not just here, but around the country, in nanotechnology, new energy sources and speed, new materials, new chemistry of the small, and all of that. This is all happening right now, and we are benefiting directly from it. Now some of these take a while to develop, and some of these happen more quickly. I was trying to figure out why. And in some cases, it's just they take longer. So in the regulated industries, medical, for example, it takes 20 years-ish for a fundamental discovery to really end up in the hands of the average patient or the average person who really needs it. It's really a long time if you think about it as a person in that 20 years, but that's how, in fact, our system works. It's on the order of a 30-year cycle from fundamental physics insights to their commercialization. And again, anything we can do to shorten those things make a lot of sense. And as science progresses, there's the National Academy of Engineering did a study which estimates that Moore's law is, in fact, which has powered my career, everything I've been associated with, all the industries that we use, all those phones, all that connectivity, all the knowledge that you have, is in fact slowing down. But the equivalent analysis is that the rate of innovation in genetics and biology is speeding up. So there's every reason to believe that the platforms, as they get built, will produce huge gains for society around the world. So I looked up, in 2008, the National Academy of Engineering studied the 14 grand challenges. And let me just read them to you. And I scored them as we've made serious progress on the first 6. Making solar energy affordable, did that. Engineering better medicines, doing that. Secure cyberspace, we're winning, in my view. Enhancing virtual reality, take a look at Oculus VR, all the other virtual reality tools, the explosion in 3D, various ways in which virtual holography will occur. And advanced personalized learning, that's what much of our industry is working on. Those are 6 of 14. Let me read you the other ones. These are the grand challenges from this body 6 years ago. Pretty good progress, I'd say. Congratulations. Provide energy from fusion, okay. Develop carbon sequestration methods, managing the nitrogen cycle, providing access to clean water, restoring and improving the urban infrastructure, reverse engineering the brain, preventing nuclear terror, and engineering the tools for scientific discovery. We're doing well against the grand challenges that we set out, and with more money and more focus, I'm confident that we can work on these others. I really am. So what I want you to do is imagine with me what this world would look like. And I really mean this stuff, by the way. So we talked earlier about personalized medicine. So imagine with me that we can sequence everything living. Everybody knows the cost of sequencing is now down to below $1,000 and will be soon $100 faster than Moore's law. And that you can find this drug that specifically works for your genetic situation. That you can analyze outcomes and so forth. The geneticists and biologists figured out a tool called CRISPR, which uses biology to actually screw around with the cell and change it genetically. Huge leverage from this kind of an invention. We're very close to the full understanding of how to use DNA in humans. That doesn't mean we will, but to actually understand what it does. And you can imagine that in our lifetimes, the turning on and off of the alleles that actually control gene expression, basically, will be possible. The impact on people's lives, the quality of their lives is extraordinary. Let's think about transportation. I use the Isaac Asimov quote to both showcase what Google was doing, but also to showcase that you could be right in 50 years. Think about the number of deaths that occur in America on highways, more than 31,000. By the way, that number is on a mileage-adjusted basis the lowest it's ever been. But every one of those deaths could be prevented if you had the perfect autopilot driving you, especially if you're drunk. And if you're confused about this, when you imagine putting your teenager in a car, would you like to have a self-driving car option? You betcha. So think about education. Think about what education means. All of us grew up in the traditional model, rear ends and seats, looking at a blackboard or a whiteboard or what have you. Imagine instead lifelong learning that's tailored to who you are and what you need, and where the computer sort of talks to you in some interesting way and figures out not just the things that you're best at, but also the best way you learn. There's an awful lot of evidence that people learn in different ways, that people can learn in short spans, long spans, gamification, so forth and so on. We're now running all of those experiments in all of these online worlds. And for those of you who have lived or have grown up in rural areas, one of the great tragedies is you have one of these sort of brilliant kids in a rural area where there's just no way to educate this kid, you know, a boy or a girl. Their brain just goes too fast. Well, now we've developed those tools, and we will see them as great scientists, great leaders in America. Think about automation. We've already done this to some degree, and it's getting better. Repetitive tasks, right, which were the bedeviled of humans for many years in manufacturing, are now being replaced by robots so that people can actually work at a higher level, a more appropriate for human skills, where the robots can do the things that are dirty and nasty. Let's think about biology and medicine, synthetic biology. The ability to computationally simulate what biology can do, right? It's a whole new field where the marriage of supercomputers, big data, and the understandings we have of how biology works allows us to, at some level, both understand the process of life and also begin to create small examples of new life. Tissue engineering and stem cells can now be used. There's a Nobel Prize winner who figured out how to generate stem cells out of the blood of normal people as opposed to out of traditional, the other kinds of cells. And so as a result, specific growth engines, if you will, can be generated for each and every one of us to do the things that we need to stay healthy. Think about, and by the way, you sit there and you go like, okay, I already know all of this. Well, did you know that the average lifespan until the Middle Ages was between 20 and 30 years? Right? All the estimates are that for 2,000 years, people would die somewhere between the ages of 20 and 30. Women largely in pregnancy, men in war, and then the early diseases that we now can cure. The manufacturing, super strong materials, very light, that reduce energy consumption. And remember, a lighter and more powerful car is also a more efficient car. Right? There are estimates that cars can weigh 5 times less because of these new materials. And I'm talking about many, many things. There's a whole revolution in this going on. Who would have thought that we could use big data and smart grids to save 10% or 20% of the energy consumed by America? These are the estimates now, literally from energy wasted, not even from better cogeneration and those sorts of things. What about cities and rethinking cities? It's pretty clear that cities are the creative engines now in the world because of the sort of need for people to be next to each other. People are now mapping out what would a new city be, mostly in countries which are developing new cities like in China, and for places where we aren't building new cities like America, reimagining how they'll work, the instrumentation of that data, the ability to make them more efficient, to deliver the services that people care about. There are all sorts of funny examples. One interesting correlation in Chicago is that there's always a correlation between a water main break and a rat infestation. So you're sitting there going like, is that causation? And everyone has convinced themselves it's not. However, what they've learned is that when the water main breaks, send the rat people. And you know, if you have a rat in your neighborhood, you actually care a lot about this. But the fundamental shift, I took you through that list, is a fundamental shift in understanding. The part I want you to understand the most is the ability to make people smarter and understand everything. We are on the cusp of a set of discoveries in artificial intelligence involving vision, speech recognition, text. By the way, you sit there and say, well, how does this apply to me? You use this every day, by the way. When you use any of the voice recognition products of Android or iPhone, they all use the same algorithms. When you use Google, which I hope everyone here does every day, you're using all of these tools. They all exist. They're all in development. There's been huge breakthroughs. One of the more fun examples is that a team at Google decided to build a system, and they didn't quite know what it should learn, so they let it watch YouTube for 11,000 hours. And so the question was, if you watch YouTube for 11,000 hours, aside from being kind of bleary-eyed, if you're a computer, what do you learn? And it learned two things. It learned how to recognize human faces, eyes, nose, and mouth, and it learned how to recognize cats. I'm just reporting the news. So imagine the supercomputers that are being built now with vision and voice and image recognition. What will be possible 5 or 10 years from now as we finally break this through? Well, my favorite request is the one that reads my email for me and says, does Eric want to go to Philadelphia or want to go to DC? Which restaurant do you want to go to? Do you want to spend Saturday here or Saturday there? And the system should be able to get to the point in our lifetimes where they'll be as good as a very intelligent personal assistant. Right? Somebody who knows enough about your preferences. And will you use this? You betcha. Why? Because you're tired of answering all these stupid questions to yourself, and you'd much rather have a good time and a good life and work on the things that you really care about. With our permission, right, with your permission, we will really begin to share much of this information online. The result of this is we're going to have amazing IQs, absolutely amazing IQs. And this applies to everyone in this room and everyone outside the room too. Because everyone benefits from having a computer and a system that can anticipate, can help them, can make suggestions, and be nice, right? Now, what does 100 years look like from now? Well, of course, no one has any idea, but I'll make something up anyway. Can you imagine that 100 years from now will be so good at this that the essence of you, your personality, your judgment, will live on after your death? That it's so good that literally you could ask it a question and it would answer as if you were still around. Maybe. We will see. What do we do? What do we do as a matter of public policy? This is an H.G. Wells quote. Civilization is a race between education and catastrophe. Let us learn the truth and spread it as far and wide as our circumstances allowed, for the truth is the greatest weapon we have. I can think of no better rallying cry for this group and for the National Academy of Sciences, National Academy of Engineering, National Academy of Health. I would argue that the country, and globally it's true too, have to take a position of principled growth. Growth in the knowledge economy, growth in science, growth in energy, all the things that I've talked about. I would also tell you that not all problems can be solved right now. And the Americans love, we want to solve every problem right now. But wisdom says that not every problem can be solved right now, but maybe some we can let go and some we can focus on right now. Let's focus on the cities and the infrastructure of knowledge and the educational systems to get us all connected to actually make this stuff happen. Let's understand that innovation comes in all forms, not just in science, but in creativity, in movies, and art, and so forth and so on. And let's let the social agenda take care of the rest who are not as fortunate as we are to be as well-educated and curious as we are. And let's come up with new ways to address inequality that are created by all of these new tools. And I was thinking about, so before we came over here, we walked over to the Lincoln Memorial. It's a very patriotic place, the mall and so forth. What is America about? Well, America is about small businesses and entrepreneurs, right? And self-reliance. That's where we came from. So here we have this stereotype now, and I'll use stereotypes are obnoxious, but I'll use one for America. Think of it as capitalism without a heart. And let me use an obnoxious characteristic of Europe, right? heart without capitalism. Sorry. So why can't we have both, right? Why can't we find a path through this consistent with the principles that I'm talking about? Why can't we have capitalism and heart? What I am absolutely convinced of is that the next generation of people, the next generation of scientists and leaders following us, in particular following me, are smarter and better prepared than ever to take on these challenges. It is a true privilege to be here and to honor the National Academy and you all. Thank you so much. That's okay. Thank you again.
Thank you very much, Eric. Thank you very much, Eric, for a most insightful and moving presentation.